In the last video, we talked about volume source. Now let's discuss velocity, which is very important for the simulation. Here we need ground collision, but before adding that, let's organize scene. I don't want to connect this way, right? So I'll just delete this and I will just copy this over here. One more node to input there. Cool, that's it. And let's just talk about what we learned here. And so this is the geometry scale we have. After that, we are scattering some particles on it, and we have attribute as well. And this is converting that into volume. After that, we are using this as a source. And here we are just using this object, source, and brain over here. And after that, we are calling everything over here. So let's just name this import dust, and here's the default object, which is this one. Yep. So if I zoom in and visualize this over here, I need ground collision, and for that I can quickly use this ground collision. And if I use merge over here, it has that left input affect right input, right? So I have to merge this first, and after that I can use this merge. So let's just reset the simulation. It's working. If I go outside and just cross check, yep, it's working. But for this kind of flat surface, we can even use simple approach. So here, if we select this, we have some max size and boundary conditions as well. So what max size and everything? Let me take a screenshot. So in old school Pyro solver, we have to define the boundary where we need to simulate. So in that boundary, we have option that we need to collide with this boundary. But with sparse solver, it's very smart. So wherever there is a source, it will start emitting without defining domain for this one. So here also we can, without defining this domain, we can mention that we need to close below y-axis. Yeah, so as you can see, it's very fast, and if I reset the simulation, it will take lesser time. And one more tip I wanted to give you. So as you can see, this is really close to the grid, right? So if it's not close to the grid, right, so it is somewhere here in the axis. Will it still simulate? The answer is no. It's not simulating. So why? Do we need to define domain for this as well? Nope. So if I select this, I have one option, enlarge fields to content sources. So as you can see, it's emitting something over here. Now if I reset the simulation over here, it will simulate that. Sometimes it's not close to the grid, it won't simulate if you don't turn on this option. Well, and now I want to disable this disturbance. Yep, let's just check this now. And we can delete this transform. So now what we need over here is inheritance of the character. An object in motion stays in motion. So for that, let's talk about velocity. Yep, so I have this sphere moving around, right, in 3 axes. So velocity is vector value. So it has 3 values, x, y, z. I want to calculate speed, which is single value, meaning it's a float. So I need magnitude of vectors. On paper, I have to calculate vector speed is equal to square root of axis x, y, z. So for now, let's take 1, 1, 1 axis. It will look something like this. So if we combine all of them and we find a square root value of that. This is the actual speed if we use this 111. So that's maths behind it. So Houdini is a smart calculator. We can easily use length function and get that speed value, and even we can link that value to any color we want. So here let's just add some color as well. Most trickiest part in like simulation is when it stop moving, it should stop emitting as well, right? So where we can use this maths. So let's implement this in Houdini. So I need velocity, so let's calculate velocity of character. We can just put trail over here, compute velocity, and if I middle click over here, it's not there, so I need to attribute transfer that. So it's there, right? So let's just visualize how it looks. So if I go over here, it's not there, right? So if I want to view that velocity, I can just go over here and click V, and let me just check. Now I have that option. Yep, it's working. And here also, this is how velocity looks like. And if there is anything wrong, we can just cross check over here. We can see something in viewport. It's not actually there. We need to reset the viewport. It's removed. Cool. Let's just reduce this. I want to set some limit over here. So I'll just transfer in this distance threshold only. And now save this. Cool, we have it over here as well. But if I select this, I don't have it over here anymore. So Pyro source doesn't transfer that velocity. But if I use V and even select this velocity also, it won't take that value. So it's better we use this attribute transfer again to get that velocity in here as well. Set the radius to 1. Yep, it is there now. So simply we can write V over here and it will add that velocity field. If I middle click, you can see it's velocity field, right? So but if I go like high resolution, right? So if I middle click, just check how much voxel it's consuming over here. And at the moment it's 9 MB. So if I remove this velocity only, you can see velocity is taking 6 MB, and this is just really small source. Just think about the what if you are working with large scale, right? So in that case it won't be helpful. So it's always better to use this separately. And here we will have fixed voxel. Maybe we can just use 0.5. That's the value. Let's just check how 0.5 looks. Yep, for velocity it's fine. We don't need that extreme resolution in here. And now we can merge this. Yep, it's working well. At the moment it's too high resolution. Let's just reduce that. Yep, and one more thing, as you can see it's stopped over here, right? So I don't want to emit smoke over here. So for that, let's just make some room, as we will add some extra nodes over here. So for that I was talking about the length, right? So let's use that. So we will use point triangle. Right, so here if I middle click, I have that density attribute. So let's take advantage of that. We can manipulate density attribute over here. If I just type density 0, yep, it's working. So what I need over here is I want to link this to velocity. So let's type at speed equals at v. So at the moment this is vector, so we need to check the value of this, what's happening over here. So we can just go to geometry spreadsheet, and here I can just check the speed, right? So we are getting some speed. So this is vector value first, so we need to convert this into a magnitude, right? So let's type length of velocity. Yep, so this will give me some value. And if I go over here, yep, it's working. Let me visualize this. Is it working? So we are getting very low value over here. This is quite high value, but still, yeah. On this frame, as you can see, it's going above 1.4, right? Let's just visualize this over here. So to visualize this, we can just use CD, and let's just set that value at speed. It's 0, 0. Yeah. So as you can see, if it's moving, it's okay. I need some value here as well, so it's easy to visualize this. So when it's yellow, it will emit, otherwise it won't emit. So that's what it's doing. And here, as you can see, some of those values are going above 1, so we need to feed that value. So we can just simply type feed 0, 1. So it will just stay between that value, it won't cross that over here. Can you see? Cool. So I think now it's time to multiply that with density. So whatever above value we are getting, we need to multiply that with speed. Cool. So now if I check, yep, that's exactly what we want. So now let's just check. So after adding velocity also, it's not working. So we have added velocity over here. So as you can see, it's still density, right? So we need to change the name of this V over here. And if I middle click, now we have that velocity. Let's reset the simulation. Still it won't read that by default. Now let's dive inside. We have to make sure that we need to read that velocity over here. So if I type V and V and it's a vector, will it work? Still it won't work. Pyro solver doesn't understand V. So what it understands is well. So we have to make sure we properly type these things over here. And now if I check this, reset this, awesome, that's working. So an object in motion stays in motion. Cool. So we have some operations as well. We can subtract, multiply. So you can always explore these things, what it's doing. You can just use extreme number over here as well. Right, so these things are useful in some cases, but in this case we can use add only because we want to add velocity per frame. Yeah, so I will recommend to test all this operation for better understanding, but for now that's fine. Let's just go with one scale and let's make a flip book. Let's play this. Yep, this looks cool, and we will add some microsolvers next. Before exploring microsolvers, I wanted to mention that around 80% of the audience watching are not subscribed. In our industry, we have a limited audience, and your support means a lot. If my tutorials are helping you, please consider subscribing. It's free for you, but it will motivate me immensely to create more content for you. Additionally, if you'd like to support me further, check out my Houdini files and tutorials through the link in the description. These setups are well optimized and easily modifiable to meet your requirements. Thank you for your support. Now let's continue the tutorial. Initially I was showing microsolver, so this is the right time to talk. So it's good to add microsolver after adding velocity in the system. But as you can see, the current velocity looks quite boring. We can modify these before adding any microsolvers in here. So as you can see, we can visualize this velocity over here. So do we have any option to visualize that at SOP level as well? So let me just go over here and check velocity. So we cannot visualize this way. So there is a different approach for that one. So for that we will use volume trail. So first input needs point, second input needs that volume velocity. So here we can just use scatter. We can just scatter some points and connect this over here. As you can see, this looks very straight and I want to modify this. So for that we can use volume velocity and I can just connect this. So to add noise, we can just go to curl noise tab and let me add. Yep, so it's adding. So here I can just make some changes. So let's just use 0.25. So is this noise fine? Yep, it's fine. And in fact, we can increase this grain as well. 0.75. Yep. And let's increase scale as well. So as you can see, this is how it looks right now. Let me reset this simulation after adding volume velocity noise. Yep, there are some breakups and there is too much force at the moment. It won't inherit that much, so we need to reduce that. So let's just reduce by 0.1. So let's just, and before making flipbook, let's visualize this in more better way. So to visualize this, let's use bake volume and we can connect this. So if I check this, I can just increase, let's just use 100 and change the color of it. Yep. And this is one way of visualizing, and there is another way also. You can use volume visualizer. So here also it's quite easy that we can just go here and mention the field, and after that we can use infrared. So if there is a high density, it will show different color. If there is a low density, it will show different color. Cool, let's just visualize this now, make a flipbook. Yep, this looks cool. We can enhance this by adding microsolvers. So let me just pin this over here and let me just quickly introduce. And current block size is 0.2. So is it working? So if I check 0.2, yep, it will work. That's fine. So for this scale, 0.2 is quite better. And yep, let's just make a flipbook. Let's reset the simulation and check the difference. Yep, we can see some difference. Make a flipbook. Yeah, this doesn't look right. So what's happening over here? So disturbance is working, but it's continuously adding noise till the end. So we don't want that. So as I have discussed then, it's a good idea to add microsolver after adding velocity. So if I just disable that and if I check inheritance value over here, so as you can see, there is force when it emits and after that it just slows down. Based on that we can add disturbance. And yes, I'm talking about the length only that we have discussed. That's why I was talking about in that depth. So how we can use that over here? Do we need to use wrangle to length? So the answer is no. Pyro solver sparse is quite smart. So if I go to the simulation tab, I have that calculate speed field. So what it will do? It will just give same simulation, but it will add one more field which is speed, and we can use this field to drive that disturbance. And how we can control the disturbance? If I go to shape and I have that option control, and here I can mention speed, and I have to give control range as well, so minimum and maximum over here. So here I don't want to put any random value, that so we won't have same speed object every time, right? So we need accurate value with proper visualization. We should be able to visualize that, right? So here there are multiple way to visualize that. So one way is this, that here we can just input that speed and I can just load over here, and this is the range. So this is value 1 and this is value 0. So I want to set cutoff till 5, right? So it will add that disturbance on red value only. So at the moment red value looks lesser, so maybe we can just reduce this value. Let's go till 0.8. So I need little bit only, so I can just break this shape over here. Let me just use that 0.5 and 0.8. Let's just reset this simulation. As you can see, there is a minor difference. That's what actually we want. And let's visualize this now. Cool, it's working quite good. And one more tip, you can use this multi-field as well for visualization. It's similar like volume visualizer if you don't want to use that way. And one more thing, so this simulation looks cool, but there is something wrong. So if we follow the real physics, there is always atmospheric drag. So there will be like impact and simulation should slow down over time. So here also we need that similar behavior. So we need atmospheric drag. So let's just find out drag. So we have some drag force, but so those are for particles or RBD. But here, if you want to apply this over Pyro, we can use DEM. And where we need to connect this, we can connect this in the forces. Let me just use merge and I can just connect this. So let's just leave this default value and check. So always just check default value and you can just go extreme. Let's try both value. Yep, it's working. Let's just check extreme. How is it working? It's giving some weird result over here. Let's just check one value only. Yeah. So as you can see, extreme value is not working. So good range is 1. Yep, it's working. So I think we don't need that. Maybe 0.01. So this is always depend on which reference you are following, right? So always follow some reference. For now, I'll just go with this value. I think that's fine. Cool. So now we have drag. And after that, let's add wind as well. So we need large noise for that. And if I select these, let me just increase size. Maybe I want this large wind. So let's just use turbulent for that one. So I can just go here, simply use gas turbulent, and I want that large swirl size. Cool. Let's just check what we are getting over here. Let's reset the simulation. Yep, it's working, but it's too much. I have to reduce this. Maybe 0.01, or let's go with 0.02. We did need that less value. So as you can see, wind is working. But what's happening over here? If I go to just this tab and visualize that, it's changing noise pattern, means it has some animation also. So if I go to this pulse length, so it has some noise, animated noise, right? So we need less animated noise. So to slow down, we can just increase this. Let's just check this now. So it won't be visualized this way, but we have reduced it. Can you see? It will stay in the one direction only. So if we don't use that, by this frame, it will change the direction. Let me reset the simulation. Yeah, it's changing its path a lot. So it should move slower, means the noise over it, and we can just overall reduce the scale as well. So this will be really minor effect, but it will work as a wind overall. So that's fine. Cool. Let's just simulate this. Everything looks cool, but I don't want this in the simulation. So how we can break this edge over here? So first we can play around this with the speed and everything, but we don't have to depend on speed. We have other controls as well. So such as we can just check out density. So which frame was that? It's 79. Let's go to 79. Okay, so just check this. Let me reduce this. I want to cover more area. Yep. So this range is fine. So here we can introduce one more disturbance with same block size, and I want to use density over here, and we have defined the 0.5 4 and 0.7. This will be the range. So let's leave everything default and just reset the simulation. Okay, so there is no effect. We need to increase this, double the amount. So after trying everything, we are not able to find the solution. So that's hidden over here, threshold range. So this is the minimum range. And if we check over here, so this is the minimum range it has over here. So we need to disable that range in order to add that. So here we can just keep everything default, and if I just show you this real quick, it will apply that. Right now you can see we are getting that noise over here. That's what we want, and we don't want that much. Let's just reduce to 60. And in fact, now let's just reduce the voxel size for better quality, and let's just quickly check that.